Lesson 11, activities number 2. Find the critical numbers and then use both the first and second derivative tests to decide whether they are local maxes or local mins. We'll use the hint when we're ready. So here's the function 2x cubed minus 12x squared minus 30x plus 1. First step for both of the processes we're about to use, the first and second derivative test, is to find the critical points. So that means taking our derivative, 6x squared minus 24x minus 30, finding out where it's undefined, which is never, and also finding out where it's equal to 0, and that's what we're after. And so now we'll read the hint. After you found the first derivative, factor out the GCF. So let's do that. So I can factor out 6 only, but I think that's going to make the rest of the factoring easier. And then hopefully we see that this thing in the parentheses is potentially going to factor further into 2 separate linear factors. So you can pause the video here if you want to, but the goal is to try to figure out what's in the 2 blanks, what numbers are we going to put there. So however we do it, hopefully we get -5 and +1. You could do a trial and error thing or a box method or factor by grouping, lots of ways, but you just have to get here somehow. And then we set each piece equal to 0, including the 6. 6 equals 0 does not give us any solutions, but this middle one, you can add 5 to both sides and get x equals 5. And here you can subtract 1 from both sides and get x equals -1. So those are our 2 critical points. Now the process branches into 2 different possibilities. We'll use the first derivative test, and then we'll use the second derivative test. In both cases, we need the numbers 5 and -1. So first derivative test, we'll put the numbers here on our number line. Notice it is conveniently already labeled correctly with f prime because those 2 numbers came directly out of f prime. And now we're going to plug into f prime. You can use any version of f prime that you have. We've got this original one, we've got this slightly factored one, and the completely factored one. I'm going to highlight the one that I think is easiest. It's this one right here, fully factored version. So if I plug in a number bigger than 5, for example, 100, right here for x and right here for x, that's a positive number. It's 95, but it's just positive is all I care about. Plugging 100 here gives you 101, but it's positive. Multiplying by 6, I got 3 positive numbers all multiplied together, so positive at the end of the day. Let's pick a number in here, for example, 0. 0 here gives me a -5. 0 here gives me a +1. This 6 is always positive, so that whole thing there is negative. And then finally out here, for example, -100. 6 is positive. Negative here gives me -105. Negative here gives me -99. Multiplying that together gives me a positive at the end of the day. And so then again, we're just thinking about if f prime is positive, then the function increases. And if f prime is negative, the function decreases. And if f prime is positive, the function increases. So I can see that I've got a maximum right there at -1 and a minimum right there at 5. And so that's all we're going to do is write in, fill in the blanks here to state that. Since f prime goes from, I'm focusing on the -1 here, positive to the left to negative just to the right, at x equals -1, f has a local maximum increasing to decreasing at x equals -1. Now focusing the attention on the 5, again it's f prime, but here just to the left of 5, f prime is negative, and then to the right of 5, positive. At x equals 5 is where we change. F must have a local, let's see, decreasing and then increasing. That must be a minimum at x equals 5. Okay, now we're going to pretend we don't have any of those conclusions. What we do need, though, is the critical points. And we'll do the second derivative test to try to get the same conclusions that we have there in purple. Okay, second derivative test first relies on having the critical points, which we have. It's still 5 and -1, but it also involves having the second derivative, which we don't yet have. So let's calculate f double prime. I mentioned that there are 3 versions of f prime up here, and you're welcome to use any one. You got this one, you got the slightly factored and the fully factored. I think for the purposes of finding the second derivative, I think actually the original is the easiest place to go. So let's take a derivative of the original form. So 6x squared, that becomes 12x minus 24. There's the second derivative. And into that function, we are going to plug in the two critical numbers, -1 and 5. -1 and 5. So we'll plug -1 in. So I get 12 times -1 minus 24. So that is just plugging -1 right in here. Ultimately, it's -36. All we care about is whether it's positive or negative, but I'll put the number here. Since f prime of -1 was 0, that's how we got -1 in the first place, and f double prime of -1 was a negative number. And now I'm just thinking about my two basic curves, one concave up, one concave down. I'm just trying to figure out which one I have. In one case, the green point is a min, in the other, it's a max. So this f double prime being negative at the green point tells me concave down, which tells me this picture, which tells me max. So f has a local max at x equals -1. And then we'll plug 5 into the second derivative. Again, that's 5 in here. So 12 times 5 is 60, minus 24 is 36. Since f prime of 5 is 0 and f double prime of 5 was positive, bigger than 0, so positive second derivative tells me concave up, which tells me this graph, which tells me minimum. Green point is a minimum. F has a local min at x equals 5. And of course, the conclusions using the first derivative test are exactly the same as the conclusions for the second derivative test. Again, just two different ways to answer the same question, but we'll get the same answer.